Well, here we are at Javelin. Welcome to Halton Tech today. This is going to be an exciting episode. We're going to take a look at actually three different aspects of this company. We're going to be taking a look at 3D printing and where that's leading us, because that's been in the news a lot lately. And of course, then we're going to take a look at some of their 3D animation. They're doing it in a bit of a unique way to eliminate a lot of the extra work that normally happens in cinematography. And then we're going to be taking a look at an Oculus. And this is a really neat piece of equipment. And this allows you to actually put on a special set of glasses and look around the room as if you were actually immersed into it. So why don't we just start walking around, take a look, and talk to Ben and Dan. Hi, and welcome back to Halton Tech today. We're still here at Javelin, and now we're going to be taking you from the 3D virtual reality to 3D reality part of their business, which is truly amazing. What basically I have here is something that they make, and it's a 3D printer that prints this product off. And this is the product when it comes out of the printer, and this is it after they clean it off. Now, the real important part to remember is this isn't just something that pops out of a printer and it looks pretty. These actually have real moving parts. They come out of the printer this way, which is where it gets very interesting. And I'm actually here with Ted Lee, and Ted Lee is going to be walking us through the entire process on how this actually happens. So, Ted, thanks very much for having us.
No problem. Pleasure to have
so
you.
Maybe you can just walk us through and take a look at how this is done.
Yeah, so the way that this works is that you start with a file that has been constructed in 3D, and just like you would print to your home printer or a printer at the office, right. The file is sent to this unit, and an operator would then take this 3D file and place it on what we call the tray, because inside the machine there's a tray almost like a cookie sheet, and right. That's where the resins are dispensed, and the tray moves down and builds the product up layer by layer. So what we're going to do is, I'm just going to take a part here that's a flute, bring that into our software, and it's going to place it. Essentially, it's giving me a rendition of what it's going to look like sitting on the tray inside of the printer. Wow. So I can spin it around in 3D. It gives me an idea of what it looks like. I can let the software do what's called an auto placement, and it will allow it to essentially come up with the best way to orient the part on the tray. So you'll see it move around here in a few minutes. We analyze the parts, figure out the most efficient way to lay them out. So you'll have seen that those flipped over a little bit and changed position.
I saw that.
So that's the least amount of material and so on that will be used, and the shortest amount of time to actually print.
That's amazing.
The job out.
And when it comes out, it's fully playable. When you clean it off, you can play this flute.
That's
it's
right.
ready to go.
So because of the shapes of the round objects, or even the item you're holding in your hand, we have to, for instance, this loop here would be suspended in midair. So as we build up from the bottom,
right.
we have to add some material to sort of sit on top of, or essentially build the mold as we go.
Right.
And that's what this is. So this outer material it's almost the consistency of cheese.
Yeah, it feels like it. When you squeeze it, it's very mushy.
It's a food-based product, and when we wash it with water, it basically breaks down and becomes almost like a gelatin, and it comes right off the part.
That's
so
amazing.
It's essentially, we're building the mold and the material as we go through the process.
What amazed me about this whole thing is the fact that it actually is workable. I mean, it comes right out of the printer working. Nothing extra was done, no parts were added. Nope. It comes right out of the spray, and you're done.
That's right. Yeah. So inside there is the clear and the black all together and done, and we wash off the water-soluble material that's supporting it, and that's what's inside.
That's amazing. So maybe you could take us through some of the products that you've made, and maybe what their purpose is, and how it's really helped the industry.
Absolutely. So the product gets used in a wide variety of ways. So the printing process itself has a lot of different applications, and things that we can do related to, for instance, the medical industry is quite amazing. So something like this might be used to understand how the foot bones and so on would fit in a shoe.
Right,
so,
and the bones are right in there.
Yeah, so this would be done from MRI data is pretty typical starting point for the data, right. And we would use a hard material for the bones, and this outer one, as you can feel, it's a rubbery material that would resemble the human foot.
Right.
So a number of our manufacturers, this shoe sole, for instance, is a good example of one of our other customers in the running shoe industry. It's quite common. So this could be obviously very much used to understand and study how the foot sits on the shoe sole. And again, the shoe sole is rubber, so the manufacturer is able to look at how those two things would behave in the real world.
Right, and first when I touched this, I thought they were hard, but that's not, that's flexible.
That's flexible material. And we can change the amount of flexibility, so inside of the unit, just like you can mix color on your inkjet printer, we can mix material to get different different stiffnesses
phenomenal.
And softness.
That's phenomenal.
So that's kind of you know, the shoes and clothing is kind of the consumer product side of things, and then the medical is something like this. Another good medical story would be this project here was something we did with Hospital for Sick Children. This again was MRI data of a heart.
Wow.
There's some problem on this heart, and the doctors were going to operate on it, so they needed to be able to brief the surgical team, the parents, and potentially build new instruments or clamps or something that they might need for this special case. So we even modeled this out of a soft material, so they're able to really get a feel for what the operation would be like, maybe how much the resistance the tissues would offer, and that type of thing.
And if there was a problem with the heart, obviously if they're at the Hospital for Sick Children, there probably is, the issue would already be in that MRI data. So they'd be able to open up that heart, find out where the problem is, and figure out how to repair it.
That's right.
Before they even touch that child.
That's right.
That's amazing.
Absolutely. So that's becoming, we're seeing more and more of this application. We've sold a number of the units into the medical industry, and it's going to become something along the lines, I suspect, of like the X-ray. This will be another diagnostic or form of presentation that they'll have to look at medical, you know, diagnostic information. So it won't just be the X-rays on a lit board. It will be you know,
wow, that's
briefing
phenomenal.
the teams and talking to the parents with things like this.
What I found interesting was that jawbone that you had, because you can actually see the teeth in it.
Yes, that's another one where, again, medical data, MRI data being used to go through and print out this kind of thing. It's quite common to use this in the dental industry, and in fact there is a number of dental labs and so on that are now using this technology, where you go to the dentist, you'll have your mouth scanned with a laser scanner, so no more impressions in that horrible gum and the metal plate that you go through. I think we all have. And so it gets rid of that. Your mouth is scanned. The scan data is sent to the lab, where they would print out the area of the mouth that needed some work, and you'd end up with something like this, where they would then maybe work on a dental appliance or an implant fitted to the client's teeth. So this is actually our dental material here, and this would be used by a dental lab to actually make
almost like a cap. Yeah.
In this particular case, it's a cap, but it could be bridge work or something like that. So
Right.
this is actually, this whole process is changing the way that dentists are working. It's being referred to as digital dentistry.
Wow.
And so the printers are used widely in the dental labs instead of plaster and the usual processes that we had in the past.
Yeah, now we were talking about this a little earlier, something that I just had happen, because I used to live in downtown Toronto, is I had to have my medical records shipped to Milton, where I live now. So theoretically, this could be on a database somewhere, and that information could be sent to the new dentist and printed on one of these printers.
Absolutely.
Right.
Yeah.
And I think that's where the technology in the industry is taking us. I could really see how that would be used.
Absolutely. Yep.
Wow, that's phenomenal. Now you also have something happening in the printer right now, but you were going to show us kind of the broken down version of it.
Yeah.
It's a fin.
It's a fin. It's a tuna fin.
A tuna fin, okay.
You can tune a guitar, but you can't tune a fish. It's a tuna fin. So this is a research project. This is a small scale version of the project. We did it initially with them just to kind of prove out the concept. So you can see that this is actually very, very fine bone structures and so on here, and this is the exterior fin. And what they're doing is, this is a scaled down version. They again did scanning, either CAT scan or MRI. I believe it's MRI, just the resolution on MRI appears to be is better, so I believe that's what's based on. And so what they're doing is studying the behavior of the way the tuna fish swims and the way the tail generates propulsion and stuff for the fish. And so this is the actual section from a tuna.
Wow.
And this is the interior bone structure. So we're printing them out now in larger scale.
Right.
We've worked through a few of the issues related to the data and how they were collecting it. So now they've got us the right information that they want us to work from.
Right.
And so we've got these on the printer now, and we're printing them out.
That's amazing.
At a larger scale.
Now, when you do this, are they done in two separate parts, or are they all going to come out really as a completed?
They'll come out as a completed unit with, again, using that sort of rubbery material and then stiff bone structure, and then they're going to be able to put it in a mechanism. I believe they're putting it in like a fluid test tank and actuating it mechanically, and then going to be studying the forces and the loads and the way that the water flows to really understand the mechanics and fluid dynamics of how the tuna is able to swim. My assumption is that it's because the tunas can swim at such speed and long distances, they really want to understand how the animal can be so efficient.
Right.
And maybe apply some of those things to submarines or boats or other
could
other
see how that would be used.
applications.
Yeah. So now the big scale version is being done on your large printer.
That's
here.
right, yep.
Okay. So maybe we'll just take a quick peek at that.
And this is actually a good example of the process as it's progressing as well. So we sort of started the job a minute ago on that flute that we were looking at on the screen. And what we're doing here is printing out the tuna bones, as we spoke about. And that sort of lighter colored gelatin that's a bit translucent, that's the support material. So it's building up the molds and the rubbery material around it. And the darker section that you can see forming is the hard bone, or the our rigid material.
I can see that.
So each time that head sweeps back across, we're dispensing a 16 micron layer of material. And then that bright light that you can see is hardening the material. So the UV energy in the light causes a chemical reaction and a change in the resins and causes it to harden.
Wow.
And interesting thing is it is only the UV light that hardens it. It isn't like paint. It's not an air dry or anything. It's the light that actually hits the material and cures it. And it cures. It's hard as soon as that light is passed over it.
That's amazing. So welcome to Halton Tech today. We're back here at Javelin at their new Cinema Suite division. So thanks very much, Dan, for having us here.
No problem.
You're actually doing some pretty unique things, especially in the gaming world. Everything that you do in 3D is always mind-boggling to me. So thank you very much for having us. Every time we want to see something brand new come out, we always come to you first. But maybe you could show us some of the new things that you're doing. It looks like you're actually making it possible for the end gamer to actually make their own pieces of the puzzle. So
yeah. What we're actually concentrating and focusing on is helping video game developers do their jobs easier, and we're developing a suite of tools to allow them to do that. So if you're using game software to make video games, and in this case our software is for the Unity game engine, which is actually a very popular game package that a lot of indie developers are using. There's actually over 2 million of them using the software now.
Wow.
So we figured, why not help them and come up with some ideas on how we can help them do their jobs quicker. So we got an idea from a customer visit last year, and it put us on a path of creating a timeline editor inside of Unity that will allow a game developer to control any aspect of the game software in time. So they can manipulate objects, the environment, they can make it rain, they can make it snow, they can control lights, and as well as animations and all that kind of thing, without having to do any scripting or any programming whatsoever.
that's fantastic, because what you were saying before all this was available, is that if someone wanted it to snow in the scene, you would actually have to completely rescript everything.
Exactly.
And you're talking a huge amount of time and, of course, a massive amount of money. So this really kind of brings it into the affordable realm, and probably people are going to start making their own mini movies, so to speak, and this is the way of getting them started.
Yeah, mini movies. Also, there's a lot of mobile game developers out there. Those numbers are growing exponentially. They've got to compete with AAA video game companies that are out there. So any tools that can get into their hands that can allow them to reduce the amount of staff they need to have to get cinematics in their game done, our tools will help them with that.
Wow, that's fantastic. Well, maybe you could show us a little bit about what you're doing here.
Yeah,
so
sure.
How about we just dive